today's lesson, we want to be able to determine if a relation is a function. In algebra, we call situations where we are sure we can predict the outcome functions. Functions are very special relationships. If you are given an input and you can't match it with only one output, it is not considered a function. So again, if something is a function, each input, which is a part of our domain, is paired with only one output, which is part of our range. For example, here's our scenario. Each person in the class has a birthday. So what would be the input? The input would be each person. What would be the output? Having a birthday. Since every person has one birthday, one input, one output, this represents a function. If something is not a function, each input, again, which is part of our domain, is paired with more than one output, which is part of our range. So for this scenario, for each day of the year, more than one person has a birthday that day. Our input is each day of the year. The output means that there are going to be multiple birthdays that fall on that day. Therefore, it's not a function. So we know in mathematics we can represent situations verbally like this. We can also look at them graphically as well. And so we have to think about, well, graphically, what would that look like? So here we have a graph of our line AB. And so graphically, we have to think, well, what represents the input and what represents the output? Graphically, our inputs are our x's. Again, these are part of our domain. And our outputs are the y's, part of our range. And again, like we said before, in a scenario, if every input has one specific output, it would be considered a function. So our inputs are here, are x's. So if I look at each specific input, so here's an input, and I look, it has one particular output right here. For this input, here's our output. For this input, here's its output. One specific output for every input. Therefore, it would be a function. And if you look, we're going vertically, right? And so no matter what input I'm checking, it only has one output. So as long as this vertical line is touching our graph one place, it represents a function. So sometimes we call this our vertical line test graphically. If a vertical line passes through only one point at a time, it is a function. If a vertical line passes through more than one point, then it would not be a function. Okay, so again, the vertical line just says, for this input, is it matching one output for the function? If that's not happening, then it can't be considered a function. So let's look at a couple of other scenarios. We want to see if these graphical representations of relationships represent a function. So let me give you a moment to decide on first these two graphs. So take a look here at the left, think about whether or not you believe that's a function, and then look at the one to the right and jot down whether or not you think that is a function. All right, so for the one here on the left, the inputs are x's, the outputs are y's. We want to check, does every input only give us one specific output? So again, let's check. If this is my input, it's touching the graph once, there's my output. If this is my input, touching the graph once, there's my output. So no matter where I test for those inputs, right, it is only having one specific output, so this would have to be a function. Well, the one here on the right, again, here's our inputs, here's our outputs. Is that a function? Okay, so no matter what input, does it only have one specific output? If I check every single input, it's only touching once, has one specific output. So yes, this would represent a function. So far we're 2 for 2. Let's take a look at this one here. We'll give you a minute to make your decision whether or not you think this represents a function or a non-function. So here are our inputs, here are the outputs. So again, we want to check, does every input have one output? So far we have no inputs, no outputs. Here's an input, one output, but look, these inputs have multiple outputs. So this cannot be a function. So to recap, two functions, one input, one output, one non-function because each input, once we get less than 0, has multiple outputs. All right, let's try a couple other scenarios. Let's see if you think these three graphs represent functions or not. So let me give you a picture of the first two. And your third. Taking a look at our graph here at the left, again, we want to see it as each input have one output. So our function, I should say our function, our relationship starts here with an input of 0, and here's our point. As we look at our other inputs, so far one specific output, and then we get to here. Now, the question is, does each input have one output? Let me move my arrow out of the way, right? So if we look at our graph, it appears that we have 2 points, right, for that output. However, one is filled in and one is not. When we're talking about our inequalities, graphing them, when our point was solid, it was included. When it was open, it was excluded. So if I have one included point and one excluded point, that means for this input here at 1, I only have one output here at -4. So that would be okay. It so far is meeting the rule for the function. If I just keep going, look, still one input, one output, one input, one output. That carries its way through. So yes, this does represent a function. If both of the points were solid here, that would be a non-function because each input would have multiple outputs, but that's not the case because we have one of each type. The one here on the right, again, here's our inputs, here's our outputs, and let's see, for every input, do we have one specific output to make a function, or do we have multiple? Well, here we go. It's touching once, touching once, touching once, all the way through. This would represent a function because every input has one output. For our third graph, let's see, we've got our outputs labeled. We have our inputs labeled. Remember, inputs, that belongs to our domain. Outputs belong to our range. And again, we're going to see, does it have that one-to-one relationship or not? And as if I go through every input, oops, that I test has one specific output. So that would represent a function. So to recap, our first two graphs represented functions because they had the one-to-one relationship. Every input had one specific output. And our third one also represented a function because every input had one specific output represented. So now that we know what to look for functions, it's going to be your turn to practice, whether we have verbal situations written out, graphical situations written out. Even remember, a graph also represents a table, right? A table could be a graphical representation because every point on our graph has an input from X and an output for Y. So we could represent it with a table like having 1, 1, 2, 1/2, 3, 1/4, 4, 1/8, and so on. We could do that as well. So you're going to practice with the various scenarios in verbal, table, graph, and see whether or not we have functions represented.